Hello everyone, in this video we are going to talk about Scraiber segmentation software. This software has been developed within the project founded by the NFTI, and the main idea is to make machine learning pipelines used within the scientific process and only available for Python developers, also available for users conveniently just through a graphical user interface. Scraiber is hosted online, available to everyone through the following URL: scraiber.acaml.org. And if you go there via your web browser, you see this page where you can first of all say from which volcano your data is, provide a label for the synth section you are using this for, and give a mineral name. In this case, just olivine. And the input data we need for this analysis are the BCF files created by the Bruker electron microscopy software. Here we see several files which we are going to use for the analysis. We select all of them, they open, and then upload. This is the moment when the files are uploaded to the server. If you upload a large amount of data, it's always better to use a wired connection to make it faster, to make the transfer faster. And as soon as the data arrives at the web server, the files are converted into easier to use TIFF files, and they're stitched to a single image. This visualization of this image we see here. This is the visualization of the backscatter electron image. And if you want to work with the stitched files, you can click on the download link above the image, and a zip file is downloaded. We can take a look into it. We have in there several files. We have several element maps which are automatically extracted from the BCF files, like for example iron, or the backscatter electron image itself. The PNG files are always a visualization, just to make it easier to interpret the data, and the TIFF files are always the raw data which can be that easily visualized through typical image viewers. Now, in the background, the segmentation, the olivine segmentation of this data has been finished. What we see here is the olivine mask. Everywhere where we see like yellow color, it's an olivine, and everything else, like this dark color, is the background. Let's take a look at the classification of the sinyl olivine. We can see it here in this table. The table can be sorted, for example, by the size of the olivine. Let's sort them beginning with the largest. We have this large olivine here, which we also see over here in the middle. And we have for each olivine provided an initial suggestion for a time. Here reg given like for the regular zonation. This one is states that it's no zonation. It's also like SUB for sulfinocrystal or really small crystals. And if we are not okay with this typization, we can provide custom types, like in this case my type. We can say that we want to download this the data for this crystal, and also we want to download this crystal. and maybe this subcrystal also. Okay, and when we selected them, we can say download, and zip file is downloaded. In the like folders for each type we wanted to download, like our introduced my type, no zoning, and subcrystal, subphenocrystal. If we take a look into it, we have for each crystal we selected, so if we like selected several crystals with my type, in this folder would be more files, and for each crystal we have the BSE data. For the crystal we have the olivine mask exactly for this crystal, and also a visualization JPEG so we can take a look to it. And this is basically how it works. The interaction with this typization and also the selection of downloaded crystals to download or not to download is important. The segmentation is not perfect. In some cases, olivines could be wrongly, some areas could be wrongly identified as olivines, and your manual interaction allows you to get the best data of this tool. And also it supports the tool itself, because we use your interaction to improve the performance of the segmentation. So this is how you contribute to this open source tool. If you have questions or suggestions how this tool could be improved, you can go to the Git repository of this tool hosted at the RWTH Aachen GitLab, and write an issue or contribute programmatically. If you want to know how to use the code for this tool programmatically, please watch the other video about the API. Thank you very much, and bye.